This is my Lab 2, Lines of Charge. My name is Megan Coffey. So to introduce the lab, the purpose was basically to approximate the amount of excess charge accumulated by a piece of clear tape that had been quickly ripped off of another piece of tape. We used Newton's second law of motion and Coulomb's law to find the charge. And in this lab, we actually treated the tape as a line charge rather than a point charge like in the first lab. So we found the net positive charge acquired by each tape to be approximately 3.32 times 10 to the negative 8th coulombs. Here we see explanations of Newton's second law of motion and Coulomb's law and images of the formulas. So in the actual experiment, we had two pieces of tape that we treated as point charges, and then in our calculations in this lab, we treated them as line charges. We assume that air resistance is negligible, that if the tape is a point charge, the point charge is located in the middle of the tape, and at the beginning of the experiment, each tape had the same uniformly distributed amount of charge, which was neutral. The system is the two pieces of tape, the surroundings are the rest of the universe, and initial conditions are that both pieces of tape had a neutral charge and were the same length of 20 centimeters. Here's our experimental procedure. Our observations were that tape B was attracted to the hand and negatively charged pen and repelled by tape A. So we concluded that tape B was positively charged and tape A was also positively charged. Here is data that we collected and data that we calculated. I used the equation for the electric field of a uniform rod to find our charge of 3.32 times 10 to the negative 8th coulombs. Then for the code, we can see I substituted in 3.32 times 10 to the negative 8th for the net charge and followed the rest accordingly. And this is what my model ended up looking like. And the magnitude of electric force and gravitational force are pretty similar. So error in this experiment, since the pieces of tape are not true point charges or line charges, we can't really treat them as such and expect perfect results. They also most likely had different charges, but we assumed that they were equal. And then we also could have handled the tape improperly, which would have resulted in a loss or gain of electrons. So what if we had modeled each of our tapes as a single point charge like in the previous lab, compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So the estimated value with our experimental data was 2.1 times 10 to the negative 8th coulombs, which is smaller than the value from the line charge model of 3.32 times 10 to the negative 8th coulombs. So these differ because we use different methods and mathematical equations to find each charge value. Because the pieces of tape are behaving more similarly to line charges than they are to point charges, the value we got with a line model is most likely more accurate. So in conclusion, we found that tapes gained a net positive charge of about 2.1 times 10 to the negative 8th coulombs when we treated them like point charges, but treating them as line charges, we found this value to be 3.32 times 10 to the negative 8th coulombs. So, and this is a more accurate estimate for the charges that they acquired. Thank you.